Hello everyone, welcome back to ThinkLab by Saurabh. So in today's we are going to learn one of the most important concept in the modern deep learning, transfer learning. And instead of only discussing the theory, we are going to build a complete real world project. So our project is going to classify image into the two category, cats and dog. So we will use the TensorFlow Keras and our pretrained model, right? And we will use the pretrained model as a MobileNetV2. And we will first use this MobileNetV2 as a feature structure. Then we will perform the fine tuning, and finally we will evaluate our model and generate the prediction and visualize the predictions and save the trained model. So by end of this video you will understand not only how to implement the transfer learning but also what is actually happening inside internally, right? So let's understand the first question, what is the transfer learning? So let's first understand the theory before writing the code. Suppose we want to build a neural network to classify cat and dog. So normally we could create a CNN from the scratch. So the problem is that the CNN trained from scratch is generally required a large data set, significant computational power and long training time. So transfer learning provide another approach. So instead of starting with the random weight, we start with the model that have already learned the useful visual features from the very large data set, right? So if you see here, for example, I am taking here. So we have to use this here the large data set, right? So I'm going to use here in the form of text so that you can easily understand. So this is the pipelining we try to follow, the same way. So let me write here in the form of text here. So you can see here, this is the large data set. We have used this pre-trained model, and this pre-trained model contained the age, texture, shape, pattern and objects, and then we use the learned features, and then we use our new data set, and finally we can predict the cats versus dog. So what is the question is, what is the pre-trained model? Because we are using here the pre-trained model. So a pre-trained model is a neural network whose parameter have already been learned from the another data set, right? So in our project we will use this pre-trained model as a mobile VNet, right? And that is already trained on the previous data set, and then we use ImageNet that have a million of images and learn from the visual features, right? So we don't need to learn all those basic visual feature again. So here you can see in the project we will use the pre-trained model as a mobile net. So let me write this complete pipeline. How can we use this pre-trained network here? So you can see here, this is the pre-trained CNN we are going to use, right? So now the question is, what is the ImageNet? Because here we are using the ImageNet. So ImageNet is a very large image data set containing the many categories object. So MobileNet is in our project used for the weight trained on the ImageNet. So we will use, first thing we have to use the MobileNet in our our Google Colab. So if you understand the let me understand two things. One is the what is a transfer learning, and another is what is a training from the scratch, right? So if you're not using the transfer learning, so you have to build your model training from the scratch. So first try to understand though, if you are going to build the train from the scratch, right? So if you're not using the transfer learning, so you have to perform this pipelining. So let me write this complete pipelining here in the form of text. So this is the previous one here. Let me write the complete pipelining here. So the pipelining will be work like this. First we have to take the random weight, right? After that we have to take the CNN, and then we have to use this we have to learn the texture, then we have to learn the shape, and after that we have to learn the object. So you can see here we are writing here this start training from the scratch, right? Random weight, CNN, learn the ages, and learn the shape and object, and finally we have to classify cats and dog, right? But if we are going to use this transfer learning, right? So if you use the transfer learning, so it will be look like this, right? So here we will directly use the ImageNet, right? And our pre-trained model we can use here the MobileNet here. So the pipelining will be look like this. Okay, so let me write here these things here. So first thing we have to use the ImageNet, then we will use the pre-trained MobileNet, right? So you can see here I'm going to write here the complete pipeline here for this transfer learning, right? So this is for the transfer learning. So let me write here this is for the transfer learning. So we will use the ImageNet, then we have to use the pre-trained MobileNet V2, then we have to learn the features, and we have to freeze and fine tune, and then finally we classify the cat and dog, right? So this why transport learning is, just reduce the amount of training required, right? So with help of this transport learning, we can reduce our training timing, right? So now we are going to write a code. Okay, so let's open the Google Colab and start writing our projects. So first thing is we have to install the Kaggle hub, right? So this is a very important, because this we have to take the data from here. So we are going to install the Kaggle hub. So let me write this code here. So we are going to write this Kaggle hub, right? So we will took the data from KaggleNet here. Okay, so it will also, as well as KaggleNet, we have to import the important libraries. So we have to import the NumPy, and we have to import the others libraries. So we have to one by one we try to install all these things. So first we have to write here the import Kaggle. So let me write those things. So you can see here we have to write pipq install Kaggle hub, right? So first thing we have to learn this part, right? After that, you already know what is the pip here. Pip is a basically Python package manager. Install we are using for the telling the pip to install the package, and Kaggle hub basically used to download the data set from Kaggle, right? After that we have to import the libraries like Matplotlib, TensorFlow, Keras, and also each and every layer we have to install the Keras. So we are going to write here this all the library name here. So let me write those all the library name so that we can directly run this things here in the cell. So first thing we have to import here all the libraries here, right? So we have to write here this first thing we have to write the import OS, right? So we can see we are going to write here the import OS. Then we have to write the TensorFlow. We have to use the Kaggle hub. We have already used the Kaggle hub. Again we are writing. So we can also, you can also not write here, right? After that we have to we have to also use this TensorFlow Keras, that will import the layer. So why we are writing this TensorFlow Keras import the layer? Because it will import all the layers like dense dense dropout, random clip. Okay, so that's why we are writing this all the layers here, right? After that, after the writing these things, we have to just put about the environment informations, right? So we have to write the environment information about the GPU and like any like others things. So we have to write here. So now we are going to write here. We have to also use the GPU here. So let me write this code here. So we are going to write. So let me write these things again. We have to write this all the parameters here, right? We have to, that will check the environment information here. So let me write those things. So first thing we have to write here all the things about the like hardware things, right? So we have to going to check the like environment informations here. So you can see here, we can see here, so here we got this GPU, right? But GPU is not available here, right? So we have to use the GPU. So now we have to go into the runtime. We have to change the runtime type. Then we are selecting this T4 GPU, right? So now we have to save it, and we are going to run all the cell, right? Once we add these things, so the GPU will be available in our code, right? So let me check here why we are writing these things. GPU is required, right? Once we understand the GPU here, then we can go with the configuration with the data set here, right? That is a very important. We have to just use the different data sets type, like we have to define the image size, we have to define the batch size, and we have to use the auto tunes, right? So this why we use this all the things, because we have to fix our this we have to resize our all the image. So we have to take the one general image size. So we are going to take the we can see the GPU time is getting here, right? We have to take the one fixed image size. So we are going to take 116 to 160, right? So you can see here we are getting the image size is equal to 116 to 160, right? So we got these things. After that, we have to you can see here why we are writing 160 by 116, because the neural network required the consistent input dimension. After that, we are putting the batch size. So you can see here we are getting the batch size equal to 32. So it means that instead of feeding the entire data set once, we will process the 32 we have to process the 32 image, right? So you can see the if you put the 32 image, so the pipeline will be like this, So let me write this complete pipeline here, so you can understand here. You can see if you are writing the batch size 32, so batch size will be 32 image go to model, then we update, and then the next 32 image, right? So that's why you are writing the batch size is 32, right, for the training of the data, and we are writing the seed 42. So it helps us to make the operation involving the randomness and produce the more random images, right? And after that, once we complete those things, so we have to download the data set. So where we can download the data set? So we have to download the data set from the Kaggle, right? So now we are going to use the data set, and we are going to write the data set from the Kaggle. So we are writing here these things. So we are writing here the Kaggle data set here, right? So you can see we are downloading the this image, cat and dog images, right? So we are also giving the data set path here. Once we download the data set, now we have to just define the path here, right? Because this is a different data set, have a different internal folder structure. So we have to define the directory, right? We have to define the directory for the cat and dogs, because we have to define the path set first, and we have to also we are going to use here the rg log, because it will search inside the subdirectory, right? Once we define the path set, then we will clean the data set here. So finally we got downloading the successful this data set. Now we have to define the directory here. So we have to defining this data set content. This is the part of data set, and this is the directory for the cat and dog. Once you run this code, we will understand where is our directory. So you can see this is the Kaggle directory. We are getting the cat and dogs. This is the test set, and this is the training set, right? So once we got this all the information, now we have to create a clean data set, right? So for that we have to just again use this directory. Now we will use this directory only, right? So we will use this first. Our base directory is the path lib, right? And this is our base directory, right? So where is the base directory here? This is our base directory. Every time we use this base directory as our complete data set, and this is our directory, right? This is the directory of cat and dog, right? So you can see cat directory found, and this dog directory found, right? So finally we got the directory. Now we are going to write these things for this is the base directory, and this is our cat dog directory, right? So once you run this code, you will get the things. So after that, after these things, we have to see the images, right? So we have to copy the images, right? So for that we have to write the code here, so that we can copy all the images here, and we can see the images here. So we have to print here the cat image. We have to print here the dog images. So let me write those things. So how can we perform those things? So we have to check the where is the cat image and where is the dog images. So let me write those things here. So we have to create one we have to write one code here. So let me first we have to define the cat file, right? After that we have to define the dog file. So let me write here this complete cat and dog file here. So first thing, we are getting the 500 image. We are going to take only the 5000 image. Then we will see we are getting the 5000 image here. Fine, this is the cat and dog. We are getting the 5000 image. You can see this is the getting the 5000 image here, right? We are getting here the 5000 image. After that we have to just what is the meaning of this code, why we are going to write here. You can see we are defining this. This is the basically correspond to our data sets preparation search, right? So first you can see this means go through the every item in the cat directory, right? You can see here we are defining here it will goes through the every cat directory. First you understand this part, this cat file, and this is dog file. So what is the meaning, why we are using this for loop here? So it is a meaning that it will go through the every item in the cat directory and keep only if it is in the file and stored in the result, right? That's why you are doing for. And same thing we also performing for the dog, and then we finally going to run this code. So you can see we are getting some images here, right? So you can see we got the cat image is 4001 and dog image is the 4006. After that, once we load this directory, then we have to visualize the training data, right? We have to load the image directory, and we have to visualize this training data. Because what is the training data here? The validation data is 20% and training data is like 80%. So we have to visualize the data. We have to visualize our training data. So let me run this code first. everything is fine here till now. So we got these things. Yeah, so we can see we have found these two classes, and this much data is used for training, right? So we have just used this, the 20% data as a validation data and 80% data is a training data, right? So this is the you can see here, if we see the entire pipelining now, if you see the this code here, so till now we have converted these things. If we check the pipelining, so till now we perform this. First we take the image from the Kaggle hub, then we divide it into directory, then we take the image data set from the directory, then we perform the resize 160 by 160, then we are putting the batch size 32, then we are put the labels cat and dogs two classes, then we go with the TensorFlow data set, right? So this thing we have performed till now. Now we are this 20% is reserved for the validation data set, right? 80% is training data set, and the base model is a binary. So we have defined this cat and dog is one. Now we are going to check whether the validation data set, right? So our validation data set, first we check this training data set. Now we are going to check the validation data set, and we also, you can see everywhere we putting here the label mode. So label mode, you can see we are also writing here the label mode is binary. Why binary? Because we have only two classes, right? So you use for the this training thing, and now we are going to use for the validation. This is for the training, and now it's going for the validation, right? So you can see here this validation, we have two classes, 165 this is for the two classes, and 1600 for the validation, right? So this is the for validation. Now we have to define the class name, right? Because till now we have going to use 0 and 1. So now we are going to define the class name here. So this is the because this Keras will just determine the class name from the directory structure. Till now only we maintain the directory, but the Keras model will just verify it in the different class name. So that's why using this here, this code here, right? The class name, you can see the class name is cat and dog, right? So we define the class name. We are taking a training data set from the class name, right? So this Keras is just going to determine the directory of the structure. Now the thing we have to visualize the images, right? So for the visualization we will use this matplotlib, and we are going to use this plt.figure. We will write the figure size, then we write the image label, and after that for visualization we have to use the ImShowImage, right? So now we are going to run this code. So you can see here we will got the some images of visualization. See, so we got the cat image and this is the dog image, right? So this is the cat image. So every different size of image we got, and different posters also, right? So this train.ds take the one batch of data set. This image is we are putting the image and label. So image will be tensor and label will be the corresponding label, right? Now we are going to perform the data pipelining and augmentations, right? While because we have to first thing, without the preface, that so first thing we have to perform this training and data validation, right? So you can see here, without the preface, the pipeline will be load, train, and load, train. But with the preface, it will be load, train, load the next batch, train, then load the next batch and train, right? So that's why we have to go with this data augmentation here, so that we will use this batch size in the effective way. So now we are going to write here train these things this preface, right? Preface we are writing auto tune, right? So first try to understand what is the concept of this pre-train and this preface and without preface, right? So let me write here, let me write the pipelining so that you can understand the importance of this preface, right? So if you see here, so if you go without the preface, right? This is the without preface. So load, train, train, load, train, right? Go with the preface, right? That's why using this preface auto tune. So it will load, train, load the next batch, and then train and load the next batch, right? So this thing will be performed here, right? So it will improve the efficiency, right? So after that we have to because we have a horizontal flipping, random rotation and random zoom. So now we have to perform the data augmentation here, right? So that it will change the random rotation, random zoom and the random flip, right? So in the augmentation we have to write here all the things about the flip and the zoom and all. So we are going to write the data augmentation Keras sequential, and we are putting the layer as a random flip and horizontal, right? And this is performing the data augmentation. So why we are performing here? So if a cat face might be left and become the cat face becoming the right. So this is the semantic class, you know, that the semantic class is still the cat, right? So it will just do the augmentation so that in every situation the cat become cat with if the face is left or right, right? And we are using this random rotation because this random rotation is the image can be randomly rotated, right? Then the class will be also same, and it can also be randomly zoomed. So what is the augmentation? So data augmentation is artificially create the variation of training images, and this can help the model and the generalize better to reduce the overfitting, right? Now thing is the mobile net will come into the picture. So this is the important section here, this mobile net. So now we are going to reaching the heart of the transport learning. So mobile net is a CNN architecture designed by designed to just relatively efficient and lightweighted. So we can load the code here. First we will load the code, then we use the ImageNet dataset here, right? So now we are going to just load our MobileNetV2. So first thing, our base model will be the MobileNetV2, right? So now we are going to just load our MobileNetV2 here. So you can see I'm going to write here the MobileNetV2. So let me run this code here. So this is the heart of this deep learning, the heart of the transport learning, right? So this loading of this V2 is the heart of this transport learning. So let me write in the form of text here because this is the very important things. Just a minute, we are getting some, yeah. So this we are going to write here this mobile net. So we are going to load here the MobileNetV2. So let me write here in the form of text. See, we are using the MobileNetV2, right? This is the basically we can say this is the heart of transfer learning, right? So you can see we have successfully loaded the MobileNetV2, right? So you can see here the parameters of this code. We are using 168, 168, 3. So what is the 3? This 3 represent the channel, red, green, blue, and we are putting the 168 by 3. It means the height is 168, width is 168, channel is 3, right? And we are writing this red, green, blue, right? This is your thing. And also you can see we want we want the mobile VNet, right? Then we have to use our own classifier, and it will give the cat and dog, right? So now we are going to freeze our model. So right, so here we are going to write trainable is equal to false, right? So we don't update the pre-trained model weight during the training stage, right? So for that we are going to freeze here, right? So we are going to trainable becomes false here, right? So why we are writing the false here? It means we trainable is equal to false. We don't update the pre-trained model weight during the training stage. So it give us, this give us if we seek the pipeline here. So mobile net frozen and then the feature extraction. So it will be look like this. After this code, the pipeline will look like this. Mobile net V2 frozen and feature extractor, right? This thing will be go, okay? After that we have to build the model, right? So building the model, we have to define the input tensor into network, right? So now we are going to define the input tensor. So we are going to define here the input tensor. So we are writing here the input shape and the input image, right? After that we have to perform the augmentations, right? Augmentation, it means the input, then we have to perform the random flip, rotations, and the random zoom, right? We can perform on these things, right? On the augmentation data. So let me write here, we are going to write is equal to augmentation input. This is the input things we will take, right? And it will goes to here, we have to write here we have to goes to data augmentations, right? So let me write those things. We have to write here the data augmentations. So we have to write data augmentation. We are defining the one variable name x, and then we have to going to write here the data augmentation as an input, right? Once this part is completed, now we have to perform the mobile VNet pre-processing, right? because different pre-trained architecture can export in input in a particular numerical range as a format. So we will therefore use the mobile VNet for the pre-processing the functions. So this x will be passed, this x variable will be passed through the MobileNet v2. So we are going to write here, so let me write those things. So we are going to write here the x Keras application MobileNet. So you can see here it's working fine, right? So it's working fine here. So now we are passed through the model through VNet. So we are taking the base model here, right? So we are going to take the base model. Let me write there the base model, right? So we are putting the base model, right? So our augmented and processing image now entered to the pre-trained mobile VNet, right? After that, after that, if you see here, if you see the conceptually, so our processing will be look like this. So the pipelining will be look like this. So we are going to write here the pipelining. So let me write the complete pipelining here. So let me write here. So it will be look like the image augmentation and the pre-processing, and then we have to write the MobileNet, right? So we are going to write here the image augmentations, and then we will perform here, let me write these things, the image augmentation, pre-processing and the MobileNet, right? This thing we have to perform here, right? So till now everything is clear, everything is fine, right? So now we are going to move to the next step here. So in the next step we have to use the global average pooling, right? So we have to use the global average pooling, right? So it will, why we using these things, this will use for the that global average pooling compress the spatial dimension. That's why you are using here, right? So let me write this code here. So I'm going to write here the global average pooling here. So I'm going to write here, we are going to write the code here. Just a minute. Global average pooling. So we have to define in x here, right? So everything we will take in the x. So we are going to define here the x here. Yeah. So let me write here. See, we are taking the x here and we are defining the global average pooling, right? So global average pooling compresses the partial dimension, right? And we will conceptually use the feature map, average is feature map, and then one value channel, right? After that, this thing we have to use the dropout rate, right? So for the reduce the overfitting, we have to use the dropout rate, right? So it's a very important, dropout rate is very important, so because we have to reduce the overfitting rate, right? So you can see here we are getting the error here because we are already, this code is defined. Now we are going to define here the dropout rate here, right? So it's a very important, this dropout rate is very important, right? So we have to define the dropout rate here. So let me write the code for the dropout. So basically this dropout randomly disable the function for the activation during the training, right? So that's why using this dropout rate here, right? So if you can see here, we can going to write 0.2. So this will reduce the overfitting here, right? This 0.2 is reduce the overfitting. So now we are going to write here this dropout rate. This working fine. Dropout rate is 0.2, right? Now we are going to define the output layer. So output layer is here we have to use the activation function in the output layer. So what is the activation function we will use? We will use the sigmoid activation function. Why? Because it's a class of binary classifications, right? So we have to use the binary classifications. Okay. So now we are going to write the activation function as a sigmoid here. So we are going to write the sigmoid activation function, right? So in the output layer we are going to use the sigmoid activation functions. See, and also we are using their dense because we have two classes, right? So that's why we are going to use here the sigmoid, and the that will produce the value between 0 to 1, and 0 for the cat, 1 for the dog, right? Now we are going to write for the complete model. Okay, so we will use the model Keras, and also we have to write here the name MobileNet, mobile v2. Yeah, MobileNet V2, right? So now we are going to write our complete model here. So after that we have to write those things. Okay. So okay, it's getting error. So we have to run the all the code here, right? Because we are getting the error here. So now we are going to for the run one. So here in this part, here we connect our input tensor to our output tensor, and we were going to create a complete Keras model. So if you check the final architecture here, so the final architecture will be look like this. First we take the input, then we to perform the data augmentations, then we use this mobile net processing, right? So you can see the complete architecture here. So complete architecture will be look like this. We are taking the input data augmentation mobile net v2, right? So you can see here we got all this complete architecture here. So finally after these things we have to compile it, right? We have to compile the model. So how can we compile the model? For the compilation we have to use this model summary, right? So we are going to write this model summary, right? So let me write here the model summary so that we can compile. It's getting error again. So we have to write the model summary here. So let me write the model summary here. Let me write here the model dot summary, right? So we are going to write the model dot summary here, and let me run this code. So you can see this is the architecture of our model, right? You can see everything we are getting here. So this gives the summary of architecture, including the layer, output shape, and the parameter count, right? Now we are going to compile the model, right? So for the compilation we have to use the optimizer. So we are going to use the optimizer as Adam. After that we have to also use the cross entropy, because this is a class of binary classification. So we are going to write here. So let me write those things. So we are going to compile the model here, right? So after this compilation we have to perform here the feature extraction, right? So for the feature extraction we have to use this epoch, right? So now we are going to write here the epoch here. So let me write those things here, right? So we are taking the right epoch to 5. Okay, so let me run this code. Okay, so it will why we are writing this 5 here, right? First try to understand. So our frozen mobile vnet, we are going to take the 5 epoch. So this is a stage 1 of transfer learning. In the mobile vnet the base remain the frozen, and only our newly added classification layer are learning, right? So conceptually mobile vnet frozen and classification head, right? So and after that trainable function we are going to use. Once we complete those things, so then we can understand the complete accuracy here, right? So it will similar to the like ANN and CNN. So we have to plot the complete accuracy. You can see your model accuracy is getting like 100% here, right? You can see the validation accuracy is 100%. So now we are going to plot our model here. So let me just plot the accuracy here. So we are going to write here we have to plot the accuracy. So let me write here the plt dot figure, and after that we have to define the figure size, and then we have to write dot plt dot plot. So let me write those things here. So now we are going to write the complete things. Okay, so you can see here we are getting here the complete. See, this is the like you can see this is the validation accuracy. We are getting 100%, right? That's why it's showing the straight line. We are getting the 100%. So now we are going to plot the loss. So now we are going to plot the loss here. So it will be the similar to the accuracy, only we have to, in place of accuracy we have to write the loss. So now we are going to plot for the loss. Okay, so we have plotted the loss graph here, right? Now we are in the stage of evaluations, right? So for we have to evaluate our model, right? So let me write here for the evaluations we have to evaluate our model. So let me run this plot. So you can see this is a feature extraction loss, right? This are the loss here. Now we are going to for the complete loss here. So we have to save this file because we are getting the error, so we have to save it. So still we again you can see the file is saving, right? Because we are getting the error here, this is not saved, right? So we have to save the differences here. So we are going to save change. We have to remove this error, right? This we are getting the save failed. So okay, fine, we got this confirmations. So finally we can see in the stage 1 the accuracy is 100% and the stage our loss is 58%, right? So this is the stage 1, and after that we have to perform the fine tuning. Okay, fine tuning and the final prediction. So what is the fine tuning? So this is the second major transfer learning concept. In the stage 1 we use the pre-trained model frozen, then we train our new classifier, right? So you can see here this is the stage 1 with this is the stage 1. And stage 2 we will use the pre-trained model, we use the unseen, we unfreeze our some layer, then we train the carefully, and then we adapt the feature up to cat versus dog, right? So now we are going to perform the unfreeze, right? Now we are going to unfreeze here, right? So we are now allowing some MobileNetV2 parameter to trainable, right? So now we are going to unfreeze. This is the part of the fine tuning, right? So I'm going to write here the code. We are going to unfreeze the, you can see we are writing here the base model dot trainable equal to true, right? Now we are going to freeze the first 100 layer. So we are going to write here the fine tune at 100. Okay, and we are taking the from the base layer, from the base model dot layer, right? So now let me write here, now we are going to freeze the 100th layer of the base model, right? So after that we perform these things. After that, you know, why we are writing this model that 100? So this it will take the first 100 layer and those layer remain frozen, right? And later we can adapt to our cat versus dog problem, right? So now we have to perform the batch normalization frozen, right? What is the batch normalization here? So batch normalization layer maintain the internal stats. During the fine tuning we keeping this layer frozen and can provide the more stable behaviors, particular where the new data set is very small, right? So we have to write the code here. Let me write those things. We are going to write here, right? Okay, so we are putting the batch normalization here, right? After that we have to count the trainable layer, right? So we are going to count the total trainable layer. So this will give us the quick check of the how many MobileNet layer are trainable versus frozen, right? So we have to check those things. After that we recompile, right? Once this part is completed, then we will move to recompile. So we have to check there how many layer is frozen. You can see we are writing the trainable layer, then we have to write the trainable things, and we are going to check here the frozen layer, right? Okay, so you can see this is total we have, a trainable layer is 36 and frozen layer is 118, right? Now we are going to recompile. Okay, so now we are going to perform the recompile here, right? So let me recompile those things. So we are going to recompile here. This is again we are getting the same thing. So now we are going to recompile. So for the recompile again we have to use this optimizer mode Adam, right? Then we have to define our learning rate. We have to define our the loss binary cost entropy. So let me write those things here. We are going to write here. So we are going to compile the models, right? So we perform those things. So you can see here we are performing here the fine tuning, right? So notice something very important. During the stage 1 we use the 0.01 and during the fine tuning we are using the 0.001. Why? Because we don't want to make large update on the pre-trained features. Okay, so we are putting the small adjustment, right? So in the first stage it will be 0.001, is in the stage 2 0.001, right? Now we are going to perform the fine tuning, right? That is a very important. So again we are going to take the fine tuning epoch is 5, and that time you can say the loss will be the decrease, right? Previously we got the loss is like 0.58. So you can see we have to, our target is we have to reduce the loss. You can see here the loss will be decreased from this training. So now we are performing the fine tuning here. So now the model is no longer simply using the mobile VNet, as a frozen feature structure, we have to use the some deeper pre-trained layer and being to adapt for the specific classification task, right? Once we perform the pre-training, then we will again evaluate our model. We have to check our, we ever check our complete final evaluations like final loss and final accuracy, and then we compare our stage 1 and stage 2, right? We will see the difference before fine tuning and after the fine tuning, and then our compare the both result, right? That's a very important things. So now we are going to understand here. So let me write here, after this 5 epoch, we will just calculate the this final loss and accuracy for the for the pre-trained for the fine tuning, and after that we are going to compare this stage 1 and stage 2, right? We will compare the stage 1 and stage 2. So let me complete those things. Okay, this epoch 5 is completed. Now I'm going to run this final loss. Okay, after that, if the final loss, you can see we are getting the final accuracy is 100% and loss is 59, right? And now we are going to compare here, compare the stage 1 before fine tuning. You can see feature extraction accuracy is 1, fine tuning is 1, improvement is 0. So it means we are not getting, because we already get the 100% accuracy, so no need to fine tuning. But if the accuracy is less, so we can also use here the fine tuning, right? This is the more important thing here. So again we can visualize all the prediction for the things in all. So we can also save our model, right? If you want to save this our model, so we can save it, and we can also use for the any building the end-to-end project, right? So if you how can we save the model? So we can simply save the model here using this command. We have to just write the path name. You can see how can we save the model here. So let me write here, for the saving the model we have to write here. You can see how to save the model. We are going to write here. Simply we will use here the model path. We have to write the content transfer learning MobileNet versus Keras, and we have to write the model.save. So you can see the model is our saved. Okay, and we can use further for the building the end-to-end project here, right? So after the saving, you can also load the data, right? So okay, so now we are going to write the complete summary here. Now we are going to complete summary for our project here. So how can we summarize this project? So using the code, I will try to summarize this code here. So let me write this thing here. We are going to summarize the code. Okay, so final accuracy is fine, we got here. After that we have to print the improvement, and then we have to write here the, let me write those things. Now we are going to check the improvement here. We try to summarize our things with help of this code, right? So you can see here, you are able to see the we have used the cat versus dog data set. We use the MobileNetV2, and we have pre-trained weight is the ImageNet. We use the transfer learning use. We have performed the fine tuning. The image size is 168. The batch size is 62. Accuracy is in the first accuracy stage is the 100%. Final accuracy is 100%. Improvement is 0. Right. So you can see this is the final summary of this project here. Right. So in this project we have built this complete transfer learning pipeline for the cat versus dog classification. So we started with the pre-trained MobileNet model trained on the ImageNet. In the first stage we frozen the mobile VNet and used the feature extractor. Then we added our own classification head consistent for the global average pooling. Then we performed the dropout and the dense layer of the sigmoid activation. After that we evaluate our model. In the second stage we performed the fine tuning. We unfrozen the selected layer of the MobileNet, and we kept the batch normalization layer frozen and reduced the learning rate and trained the model again. And finally we compared the feature extraction accuracy with the fine tuning accuracy, generated predictions, visualization those predictions, and save our trained model and load the again. So this is an important thing to remember. Transfer learning means we don't always have to start learning from zero. We can reuse the knowledge learned by the model on the last data set and adapt the knowledge for our own problem. So that is the power of transfer learning. So if you found the tutorial useful, make sure to like, subscribe the ThinkLab by Saurabh, and share with someone who is planning to learning deep learning. So thank you for watching. I will see you in the next video. Okay, so happy learning. We will see you in the next video.